Alright, so we're going to be solving by factoring, and this starts out just like when we did factoring. We're going to do the AC method, so I would be looking for factors of A times C that add to B. Okay, so I'm going to start out with A times C, which gives me 2, and so all I'm really doing here is factoring just like we did before. What multiplies to 2 but adds to 3? Okay, so what are those factors? In this case, it's easy because the only factors of 2 are 2 times 1, and those are the factors that add to 3. But when I'm solving by factoring, I have to do one more step. So I'll go ahead and write these out as factors. I've got x plus 2, and I've got x plus 1. But what I've got to do if I'm solving by factoring is I've got to set each one of these factors equal to 0. So I've got this first factor, x plus 2. I'm going to set that equal to 0. And I've got this other factor, x plus 1, and I'm going to set that one equal to 0. And I'm going to solve these just like I would any other equation. And this is just a one-step equation. To get rid of plus 2, I would subtract 2. So my first solution, now I'm solving, so I should get a numerical answer here. I've got x equals negative 2. Over here, I'm going to subtract 1 from both sides to solve for x, and that's going to give me x equals negative 1. So that's just a very basic solving by factoring. I just factor like we've been doing, and I set each factor equal to 0, and I solve. And that won't change with any of the problems that we're doing. Now there are going to be, some factoring where we had to do bottoms up. So if I had 2x squared minus 5x plus 3, and you see that equals 0 at the end, that's the clue that I'm going to be solving by factoring and not just factoring. Okay, this little equals 0 over here. So I'm going to factor this using the AC method. A times C in this case gives me 6. So factors of 6 that add to negative 5. I'm just going to figure out what those factors are. I know the signs are going to be the same. They both have to be negative to give me a positive 6 and add to a negative 5. So I've got negative 3 and negative 2. Those are the factors that I'm starting with. But remember, we have to check for bottoms up because this one has an A term that's actually bigger than 1. So I have to do one more step here. Divide both of those by the A term. If it doesn't go, bring it up front. And just like before, I'm going to set both of these factors equal to 0. Now, negative 2 divided by 2, that reduces, so I would just reduce it. Alright, so same thing. Set both of these equal to 0. That's one of my factors. That's the other one. Set your factors equal to 0. But when you have one like this, where you had to do bottoms up, it's going to give me 2 steps. Okay, so I'm going to have to add the 3 first to both sides. That gives me 2x equals 3. And then I'm going to have to do one more step because I've got to get rid of 2 times x. So I'd have to divide by 2. And that's just going to give me an answer of x equals 3 over 2. So that is going to give me an answer that looks like a fraction. So whenever you do bottoms up, most of the time you'll get something like that, and it'll look like a fraction as one of your solutions. Over here, I just had to add the 1 to both sides. X equals positive 1. Alright, so if you had to do bottoms up, you'll usually get an answer like this where it looks like a fraction. Don't think you did anything wrong. That is expected. Now if I have 2 terms, I will do, and if those 2 terms are set equal to 0 and I'm solving, I'm still going to treat these 2 terms, if it's an A and a B, just like I would if I was factoring. But here I don't have to do the AC method. Remember, if it's just an A and a B, I will factor out the GCF. They will always have something in common. If it's an A and a B, they'll at least have the variable in common. I can factor something out. So I'll take out the A that they both have in common. They don't have a number in common, 2 and 3, nothing goes into both of those. But I can factor out the A, and these A's will cancel out. One of these A's cancels out one of the A's at the top, so I'm just left with 2A plus 3. Okay, so I just factored out the GCF. I took the A out, and now I'm going to do exactly what we did before. I'm going to take each one of these factors here and set them equal to 0. So I'm setting a equal to 0. That was this GCF that I factored out. So that is technically still one of my factors. All right, and then I'm going to set 2a plus 3. I'm going to take that factor and I'm going to set 2a plus 3 equal to 0. Now over here, there's nothing to do. A is equal to 0. I don't have to solve. I don't have to, get a by itself. It already is. But over here, I have to do two steps. I have to get rid of the plus 3, because remember, order of operation is in reverse when we're solving equations. So I'm subtracting 3 from both sides. And then I would take care of this divide by 2 on both sides. And like I said, just kind of like when we did bottoms up, I'll get a fraction if I have something looking like this. So my other solution, my 2's canceled out, is a equals 3 over 2. And that's pretty much it for that. I don't have to do anything else. Don't try to do the AC method when you just have an a and a b. Just factor out the GCF and set those factors equal to 0. And we'll also see things that are a difference of perfect squares, so it's important to remember what happens when I have a difference of squares. Remember the difference of squares, it's being subtracted, and both sides are perfect squares. If that happens, I just take the square root of each side. So the square root of x squared is x, the square root of 4 is 2, and I'm going to have a plus, and I'm going to have a minus version of each one of those square roots. So I've got x plus 2, x minus 2. I didn't have to do the AC method, but I still have to set both of those equal to 0. So I'm going to have x plus 2 set equal to 0, x minus 2 set that one equal to 0. So when I solve, I'm going to subtract 2 from both sides. I'm going to add 2 to both sides, and that's going to give me x equals negative 2. And this one's going to give me x equals, those cancel, positive 2. So when you have a difference of squares, you'll start recognizing pretty quick the pattern that makes. Take the square root of both sides, it's going to give me a plus 2 and a minus 2. When I solve those, it's still going to give me a plus 2 and a minus 2, just in a different order. But then again, you'll see some kind of like this where I've got, let's say I had, actually let me not do 4, that's 25 squared. 25x squared minus 4. Both of those are perfect squares, just like in the last example. But here I have perfect squares on both sides where there's actually a number on the left. So 25 and x squared, those are both perfect squares. They're being subtracted. That's a difference of squares. That's what we want to look for. Take the square root of both sides. Square root of 25 is 5. Square root of x squared is just x. Square root of 4 is 2. I'm going to have a positive version of that and a negative. And what I'm going to do next is just set both of these equal to 0 and solve. So I've got 5x plus 2 equals 0. So it's looking like this is going to give me a fraction. And I've got 5x minus 2 equals 0. Same thing is probably going to give us a fraction when we start solving this. There's 2 steps here, so I've got to subtract 2 from both sides. And that's going to give me 5x equals negative 2. Over here I would add 2 to both sides, and that's going to give me 5x equals 2. Okay, and then I would do my last step, divide by 5, and my answer is going to look like a fraction. X equals negative 2 divided by 5, that won't reduce. Here, divide by 5, and those cancel. X equals positive 2 over 5. So those are my 2 solutions, and that is solving by factoring.